In 2016, I was in my kitchen on Orcas Island, and there was this story on NPR about professional basketball players who become enamored with baking sourdough bread and trading recipes and naming their starters. And I thought, well, that sounds like some fun. So I threw some flour and water in a bowl and left it on the counter, and a week later, I had this stinking, frothy bowl of life. I downloaded a recipe from the internet, but despite following it to the letter, all my loaves turned into bread pucks. My loaves looked like me, dense, pale, doughy, with a little bit of tang. Now, I realized that I was doing something wrong, so I decided to rely upon the skills that I had learned as a scientist. Formulate a hypothesis, understand your model and the inputs, control the variables, be persistent, and most important, science face. I started with a starter, a SCOBY, a symbiotic culture of bacteria and yeast. The bacteria are lactobacillus, the yeast is Saccharomyces. And together they form a living thing that finds a tender spot in the heart of scientists and basketball players because you nurture it and feed it to keep it alive. And you have to be very conscientious to keep it alive because starters have a specific life cycle. We add the food and then remove the waste products. But if you forget to feed your starter, it'll die a slow, painful biochemical death. So time and culture is a critical variable in making bread. But in addition to bread, starters, the symbiosis also involves you. If you bake enough, the bacteria and yeast in your starter will colonize the skin and change the microbiome. So your starter, your bread is a reflection of your starter, but then so are you as a baker. But bread is more than just starter, it's structure. When you add flour and water, you get protein polymers, you get gliadin and gluten forming a three-dimensional matrix, gliadin giving elasticity and gluten giving the strength. And then once you've got that, you can manipulate the protein content. Cake flour, all-purpose flour, bread flour have different protein concentrations and you can play around with them, although if the protein concentration gets too high, things get a little bit weird. When you add your starter to flour and water, then you have to mechanically add strength to your dough. You're transferring strength from your arms and your hands into the starter. Not enough kneading and the dough is slack. It can't hold on to the gas. Too much kneading and you tear the gluten fibers and all the gas escapes. And that similar balance is found in proofing, where you're trying to find the sweet spot between metabolism and time. And the lovely thing about proofing is that you can control flavor with temperature and time. Long, slow proofs give you just the most beautiful, open structure. But if you let your bread overproof, the gluten weakens, the gas escapes, and your bread collapses. The other nice thing about proofing is that you can compete yeast metabolism and bacterial metabolism. At low temperature, bacterial metabolism wins, and you get this wonderful sourdough tang. If you let your bread proof at a high temperature, you get a fast rise at the expense of taste. And to tell that you've proofed your bread enough, you've got to poke your bread. A nice proofed loaf is light and airy and nice and elastic and coherent. So boop your bread dough. Oven time is magical because we kill off all the yeast and bacteria and we move from biology to chemistry. We exploit the Maillard reaction, which gives us this wonderful flavor and aroma of fresh baked bread or some lovely pita. And the Maillard reaction is incredible. It's the combination of the amine groups from your proteins with the carbohydrates to form glycosamines that then transform to ketosamines and then onto a whole host of other small organic molecules that give us the wonderful smell and taste of baked goods. And et voila, as Maillard would say, because now I can control my taste with long, slow proofing in the Orcas air, and I can push my oven temperature high in search of that perfect crust. One of the things that keeps me interested in baking is the same thing that keeps me interested in biology. The diversity of life that we see is formed from a relatively small number of building blocks. And so too with bread, it's just flour, yeast, water, and salt. But when you mix them together, you activate ancient conserved biochemical reactions. We give mechanical strength to our bread through our bodies, and in the end, we get something that is delicious and transcendent. So throw some flour and water in a bowl. Give yeast and bacteria a meal and a home. Make a starter, name it, let it grow, nurture it, stick your face in there and take a big whiff because yeast farts smell delicious. care for it, love it, and it'll nurture you. You nurture it, and it'll give you joy. Thank you.